Hello friends, good morning, good afternoon, good evening. This is Prajwal and you're watching IIMB.
Hello guys, today I will be giving you a session on the brain of many projects and open source and free to install platform, the Arduino. Now let's understand this question of what is an Arduino. Now an Arduino is an open source platform. Now for many beginners you would not be knowing what is an open source platform. So let me tell you with a common example. Now, your mother would make pretty tasty dishes for you mostly every day, every week, or every month. Now, the recipe that she refers would be a little change, or it would have a little change or extra elements, or she would have subtracted some elements from the recipe that she refers. Right, so she has the authority, or she has the power to control the dish she's making. She can either develop it by adding or removing some elements, but can she change the elements in the vegetable that she is using? No, she cannot, because there are some chemical substances or compounds already present in that. In the similar way, an open source platform means the platform that you're using can be developed by the users as well as cloned by other people. For example, the original Arduino cost around 1400 rupees in India, whereas the cloned version, which I'm holding with me right now, costs around only 350 rupees. Now that's a lot of difference. Now many people would not buy the Arduino if it was 1400 rupees, right? So they came up with a low cost, efficient idea of developing the Arduino, and this is not done by the Arduino software people, but it is done by some third party. That means that the people who invented Arduino were not responsible for the cloning, but a third party was. So as I told you in the example of your mother cooking a dish, if she would be changing the elements in the recipe, that recipe is known as an open source recipe, whereas she cannot change the elements present in a vegetable. So that vegetable is a non-open source platform. That is, it cannot be altered. You cannot have any changes in that vegetable, can you? So now I hope you have understood the true meaning of the open source platform. Now moving to the next point of the Arduino. It is an easy to use hardware and a software. That means that it can be used easily by everyone. It's not that complicated that you need to have a master's degree in it, you need to be certified in it. But yes, you do need to know the basic knowledge of C and C++ in order to program Arduino. Now come on, many beginners would not really know what is C++. Now don't worry about all this, because it's just basic programming languages, and I will be covering them in future sessions as well. Now for beginners, since we have come to the topic of programming, then what is programming? So programming is nothing but feeding a data into the Arduino or into any device. So the data can be in zeros and ones, it can be in words. So now these words by the computer are converted into zeros and ones and are sent to this Arduino. Now this Arduino later processes or reads that data and completes the specified tasks that it has said to be, that it is ordered to do by the program. So the program is basically ordering any device by giving it data, that this device, you do this. Or maybe taking in a common example, like if there are 3 people, so then person 1, you do this, lift your right hand up. Person 2, lift your left hand up. Person 3, keep rotating your head for 2 seconds. Now that is a simple program, but there is a difference between a program and a piece of code. Now a code is written in some programming language or computer language, but programming is not coding, because it's a simple difference between a sheet and a page of paper. Now programming is giving information or data to anybody. So it would not be wrong to say that everybody in this world is a programmer, but it would be surely wrong to say that everybody in this world is a coder. Now, when you're entering some data in your phone or when you're chatting, you're programming your phone to, when I press this key, this letter should pop up. When I'm pressing this button, this message should be sent to this person. So you are the one who's programming your phone to do so. So everybody who is using a phone, any smart device, or in fact any device, is a programmer. Now, even if I'm turning on a light bulb, I press a switch. Now I am telling the light bulb to turn on when I'm pressing the switch. So I'm programming the light bulb to turn on when I am clicking on the switch. Whereas coding, like the word coding is pretty much similar. Like you can get to know the meaning, you can understand the meaning of coding just by code. So it is some code words, I would say, given to any device that tells it what it should do. So that now programming can be done with or without coding, but coding is the second or the first most step of programming. So it depends on a scenario. As I told, it can be the second or the first. So when I'm programming into the Arduino, it is the first step. When I'm programming it into the phone, it is the second step, right? So now we'll move on to the third advantage of using the Arduino. Now the Arduino has capabilities of both input and output. That is, it can read input and it can give output. Now, reading input is basically just readings. For example, if you're reading a book, then that is reading input. Now, if you're telling or explaining the book to somebody, then that is giving out the output. So, Arduino can do both of them, but it cannot do it parallelly. It can do it one by one. For example, it can read one device and it can give an output to one device. It can give an output to one device after it is finished reading. So it can be only output or only reading, but both reading and output cannot be done at the same time. Now this is a very important point. I would like to repeat again. Both reading and writing by the Arduino cannot be done parallelly or together, simultaneously, right? Now moving to the next topic of today's session, that is the Arduino's microcontroller. Now, what is a microcontroller? Now, when I'm telling microcontroller, please don't be confused between microprocessor and a microcontroller, because they are very different things. A microprocessor will be used in your CPU or in your laptop, PC, desktop, etc. Whereas a microcontroller cannot do all the specification or all the functions that a microprocessor can. For example, the Arduino can only read or give out output, and as I told you, it cannot read and give output parallelly at the same time. It can run only one program at a time. Now this would be easy for people to understand who are little familiar in programming. But for beginners, it's okay. You'll get to know in my later sessions what I'm talking about right now. But the microprocessor has the capability to run two programs parallelly. That is, it can both turn on an LED and it can read a sensor input and turn on a motor at the same time, at the same time interval. When I'm talking about the same time, I mean to say the same second, the same millisecond, the same nanosecond, everything. So it has a capability to run multiple programs at the same exact time frame. So now the next question, why not a microprocessor and why a microcontroller? Now it's not that why or why not, it is how or how not. So basically, if you want to, have a basic project, turning on an LED, reading from a sensor, doing one task at a single time, so Arduino is the best choice due to various reasons which I will be speaking later in this session. But if you want to have data processing, you want processing speed, as I told you, you want to run multiple programs at the same time, then you should definitely go for a microprocessor. Now again, jumping back to the topic of a microcontroller, the Arduino has an Atmega 328p microcontroller, and if you want to find the microcontroller in the Arduino, then it's this one right here. So this is the Arduino microcontroller. Now, one information which many people would have not been familiar with is there are two microcontrollers in Arduino. Now, I know you would have seen some videos before looking at this one, so they would have told you about all this, but what they wouldn't have told you is about the two microcontrollers that are present in the Arduino. Now, as I told you, this is the first microcontroller, and this right here is the second microcontroller. Now, why do we need two, right? So this microcontroller reads and understands data from the computer, and this microcontroller has only capability to do what the computer is telling you, or to do what the program is telling you to do. So this completes the set of functions or tasks, and this reads the input or output given by the computer. Now you would have also seen other pins here, right? So these are IO pins, which I will be again telling you later on in my session. Now let's move on to some of our next topic of the day or of this session, that is the advantages and disadvantages of the Arduino. So first I would like to speak about the advantages of using the Arduino. Now the first advantage that I would like to be speaking is about how inexpensive it is, how cost efficient it is, and how you are getting the value of money of what you are paying for this. As I told you, this is an open source, which means that the original Arduino was around 1400 rupees, and you can buy a clone version for only 350 rupees. So now 350 rupees is not a lot for most of the people who are really interested in robotics and have the passion to execute what they want to do, or to fulfill their dream in what they want to do in robotics or any other field too. Advantage number 2, it has a simple, clear programming environment. So Arduino provides you something known as an IDE. So for most programmers who are not new to the programming field, they would definitely know what an IDE is. That is Integrated Development Environment. But those of you who don't really bother about it right now. But for brief discussion about an IDE, I would like to say that it helps you during programming, and it lessens or it decreases the amount of errors that you would cause or you would make during programming. So it has a set of functions stored in it. So when you're typing something, it immediately tells you that, oh, maybe you want to type this. So it's similar like Google search. When you type one word, there are some search or like search results or search that is matching to your search. So it comes right below. It's some search options or some search opinions that other people would have searched. So that is basically the idea of the IDE, and it is simple, clear, and it has a simple and clear programming environment. That is like you don't have to. It's not like very complex. You have to write a lot of code, etc. It's just a simple code which everybody would be able to understand. Now Arduino, as I told you, is the combination of C and C++. So that gives an advantage to the people who know C and C++. And those of you who know it, you have a really great advantage. But those of you who don't, it's not, I wouldn't say it's a disadvantage, but I would really recommend you to learn C or C++ before starting Arduino. It's not that you just won't be successful in Arduino without learning these programming languages, but it's that you would take more time and effort to understand this if you've not ever learned a programming language before. But if you learned any programming language despite C or C++, then it is still the same. It's not a problem at all. Now coming to the advantage number 3. Now this is an advantage that I've already spoken to you about. The open source and extensible software. That is, this is a under development board or platform, that is, it can be developed by any user around the globe who is using Arduino, can understand its basics and knows how it is working internally. So if you want to know that, then you can also search other YouTube videos, or I will be putting another video very soon about this as well. And as you know, I've told you about open source. It can be developed by anybody and extensible software. You can, any person who is familiar to programming has to know this term about a library. Again, for those who are new to programming, you don't really get messed up with all this. You will be learning about this soon. But if you know about libraries, then you would be happy to know that you can use this library or these libraries in the Arduino. So you don't have to write a lot of code. There is already a program written by somebody. You have to just implement that program in your program or in your program that you are writing. Now, speaking of software, it also has an extensible hardware. That is, there is a full schematic of how the Arduino was built on their website www.arduino.cc. So you can visit this website and they'll give you a full diagram or circuit schematic of the Arduino. For those of you who have already done some research on Arduino and are just looking on this video for some extra information, you would be little surprised, or you will be little questioned about yourself, or you will be questioning to yourself, or you will be having this query about why am I only speaking about the Arduino Uno. Now, for those of you who are seeing this as your first Arduino video, let me tell you that Arduino has different designs. For example, this is the Arduino Uno, as it says right over here. Now, there are different Arduinos as well. These are some of the different Arduinos available in the market. To be specific, these are only some. So these are not all. There is a difference between some and all, as you would know. So these are only some. There are a lot of Arduino models out on the market which could be suitable to your project, so that would require a little research. And for naming these, this is the Mega, this is the Uno, and this is known as the Nano. And let me tell you how small the Nano is. It is as small as my finger, or it is only 2 digits to be more specific. Whereas the Arduino Mega is as big as my palm. And the Arduino Uno, as you can see, is half, or 2/3 the size of the Arduino Mega. Now this is how I would compare it. So now this question arises that what is the difference between all of these 3 boards? Now you would already have seen some differences on your own. That is the microcontroller present in these. So this is a smaller, this is a larger one. So this is smaller in size, but it has more number of pins. And this is the smallest microcontroller in all of these. And one more thing is that of the USB ports. So I'm sorry I have not told you about this previously, but since I have come to this topic, I would like to explain about this too. Now you feed the Arduino program through this USB port, and you have this DC jack for providing power, and that is absent in the Arduino Nano. The second thing you would have noticed on your own is these little buttons here. There's one here, there's one right here, here. There's one right over here, Nano, so I can press this. It's a button. I know it doesn't look like one, but it is a button. Now this button is known as a reset button. Now what a reset button does is it starts your program from the beginning. That is, if you're somewhere in the middle of your program and your program is running in the 3rd or 4th line, then when you press the reset button, it starts again from the right beginning of your program. That is from the first line and the first line of your program. So if you're pressing the reset button too long, it also deletes your program. So you would again have to upload your program again. So I will be showing that a little later on my PC. Now one more thing you would have noticed is the absence of this little thing, that is the DC jack in the Arduino Nano. So this doesn't have it. And one more difference of all these microcontrollers, the Arduino Nano, Uno and Mega, namely respectively, is the cost. The main difference is the cost, because the Arduino Uno, which is this one, is much more cost efficient or inexpensive than the Arduino Mega, and the Arduino Nano is the cheapest of all. Now, namely, like if I would take the price, it would be different in some places, but approximately Arduino Nano would be 200 rupees in India. Uno, as I told you, would be 350 rupees in India, and Mega, I got it for around 750 rupees in India. Now, please be attentive, because the Arduino Mega, Uno, and Nano, the ones I'm holding here is a cloned version, and hence I have got them for lower prices. Whereas if you want to buy the original version, it would cost you a lot of money. That is, this is a 1,400, this is around $1,000, and this is around 3,000 to 4,000 rupees in India. So this is the cloned version. Now the fourth difference, I guess, is the number of pins it has. So if you know, these things are called as pins. So you can connect any wire to these. So in the Arduino Nano, it is a bit different. It is, it's kind of pointy. So one more information or one more fact right over here. So the pins which are pokey, or which, if you press on them too hard, they poke your finger, they are called as male pins. So they are called, to repeat again, they are called as male pins. Whereas the ones here that, I can just run my finger across and they don't poke me, so they are called as the female pins. And these male pins fit right into these female pins like so. Now this is just an example, please don't do this at home. So this is a straight, do not try this at home, because this is a pure short circuit, and I am just doing this for an example. And as you can see, my Arduino is turned off. So you can just remove these like so, and these will go in like so. So same here, the Mega has female pin, so I can just connect the Nano here. Like, please don't do this again. This is a pure short circuit for entertainment purpose only. So I can remove this like so. It comes out, it just pops out. Right, so that is the difference between the Arduino Mega, Uno, and Nano. And again, a reminder, there are many more other boards out in the market which you can see, or you can Google it too. And let's move to the next topic. Now I will be speaking about the differences of Arduino Uno, Nano, and Mega. I have covered most of them during the explanation, but I had left out some of them. So the difference number one, the number of pins these have, I/O pins. So these are known as I/O pins. It stands for input output pins. So the Nano has around the same number of pins as the Arduino. It has 14 digital pins and 8 analog pins, and it has power pins, just like the Uno, but the size and the processing speed is much more less than the Arduino Uno than in the Arduino Nano. Now you would have caught me telling this word of digital and analog pins. So just to be more specific, these are digital pins and these are analog pins. As you can see, it's written right over here. Now what digital pins do is either it can read 0 or 1, or it can send a 0 or 1. That is, it will only turn on or off any device. Whereas the analog pin, it can turn anything, half off, half on. For example, this LED would be at its full brightness, or it would be off. And the analog pins, the LED brightness can differ. For example, it could be regarding the program. That is, it might be complete brightness, it may decrease to half brightness, and then it might turn off. Or maybe it can decrease to 1/4 brightness again. It can increase half brightness. So it can range from value 0 to 255. And in the Mega, the number of pins are way more than the Uno. Namely, it has 53 digital pins, 16 analog pins, and it has the same number of power pins. So the power pins include 5 volt, ground, and VN. So the other pins, don't bother about them. They're like after you are little advanced or onto the next level of Arduino. So the ground pin, okay, that is present in all the three Arduinos, right? Like all Arduinos to be more specific. The ground pin is nothing but the cathode or the negative terminal, and the 5 volt, that is 5 volt, 3.3 volt is a positive terminal, and it is used to give extra power. And the V in, so what the V in does is, instead of this DC jack right here, you can directly connect a battery to the V in and the ground pin here. So this is the ground pin and this is the V in pin. So if you connect a pin here, then the Arduino would be powered on without the DC jack or USB cable. So if you have noticed some pins here, and here in the Nano, then please don't bother about them right now, because they are for high level programmers or users only, and users which are very experienced in programming and in Arduino, so they would know a lot about Arduino. So I know what these pins are, but I would not like to tell you, because if you do, you would definitely do a research if I would tell you, and more research would confuse you on this because you're still a beginner. So we would be covering this in some future projects. So I have used these pins and they are very useful too, but please don't do any research on these pins, because you would just tend to confuse yourself even more on the topic of Arduino. And at a time it may happen that you will be scared of Arduino and you would be like, what is this? Oh my god, it's so complicated. But please don't come into this confusion, because it is not complicated at all. Once you've understood the basics properly, then it is a piece of cake, just a cakewalk. So you have to do more research on this. So just don't stop on my video. I would recommend you to see some other videos, especially Google. So you can Google everything on Arduino and you would get some, you would get information on Wikipedia, etc. But those, they are statements, so not many of you would understand. So you can just write down some statements in the comment box below, and I would be more than happy to explain or lengthy those statements, and I can make you understand better. So now let's come to the next topic, and in this topic we will be going in deep of the hardware components present in the Arduino. So now I'm taking the Uno because it's most preferred by most people for their projects, explanation, etc. So let's begin. Now I would not be explaining these components completely in detail, but I would give you a brief idea. And for most of you who are already familiar with basic electronics, etc., would find this pretty interesting. So let's begin with the next topic. Now the internal components of the Arduino. So I will not be explaining all, but yeah, some. So this is a voltage regulator. It is used for the DC jack, USB cable or USB connector, everything. So Arduino needs only 3.3 to 5 volts of power in order for it to function, and more amount of power would burn out the microcontroller. So this voltage regulator decreases or even sometimes increases voltage slightly. So let me be more specific, slightly, not a whole lot, slightly, so that a microcontroller can function successfully. Now these are two capacitors. People who are again interested in electronics would definitely know what a capacitor is. Then this is a crystal. This is a microcontroller, as I've already told you. These are LEDs. So now this is an LED which is internally connected to pin number 13. So it's connected to pin number 13 right here. So this LED, it's written as L here. Then there are two LEDs known as TX and RX right below it. So they are nothing but the pins connected on 0 and 1. So 1 is used to send any data and 0 is used to receive any data. So they are something called as serial communication pins. So serial communication is a next topic, and I would not like to explain this in detail right now. Please don't get me wrong, but it's just for your good so that you don't get confused, and especially beginners. So serial communication is used for communication between two devices. And next, this is the on LED. So the on LED tells us that the Arduino is on, it's boot up successfully, running successfully. This is a push button known as the reset button, so I can just click it. Then again, this is the microcontroller, ICSP pins, digital pins, power pins, and analog pins. And there's nothing really much behind the Arduino, so I would like to show this to you too. So just a 360-degree view of the Arduino, just a few seconds. This is the front, this is the back, the side, this side, the front, this side. So this is where you connect the USB cable, the DC jack. So I'll be showing you how to do this when I'm explaining this more in detail. Some of my other videos about when I'm making a project or basics of Arduino. This is the other side. So that's it for this topic, and let's move to the next topic.